so here is a infrared sauna that plugs into the electric power grid, and it produces therapeutic levels of heat and or infrared light. And there's a lot of research that has shown a variety of benefits to the human body. But one thing that is not really talked about is the downside of using a device that plugs into the electric power grid. And those downsides are known as EMF, electromagnetic field. With something like this, there are two main types that we're concerned about: electric fields and magnetic fields. And many sauna manufacturers have made claims that their sauna is low EMF so that you get maximum therapeutic benefit with minimum downside on the EMF front. In my testing and many of my colleagues' testings, it's not good enough, and many of these claims are not accurate, not properly tested and vetted. So my clients have this custom-made sauna from a well-known brand that is in a custom wall enclosure. And during the testing of their home, took some readings in here and noticed that, yes, the EMF portion of this is higher than we would like to see and is robbing them of some of that therapeutic benefit. So we're going to actually pull this out of the wall, apply some shielding material, and check before and after results. And this may be quite useful. The material that I have in mind for the shielding is quite inexpensive and could be really used on any type of sauna that's out there, as far as actually the ones that plug into the electric power grid. So let's get some before and after readings. So here's how the EMF piece works. I mentioned two of them, electric and magnetic fields. The electric field will be present when the device, in this case the sauna, but it could be anything that plugs into the wall, is simply plugged into the wall, and that circuit at the electrical panel is energized, is turned on. That thing, the sauna, the blender, the lamp, it doesn't actually have to be turned on. As soon as you connect it to that energized circuit, you will have an AC electric field that radiates out. You can think of the electric field as like pressure, water pressure inside a hose that's not actually spraying water, but it's expanding, it's pushing on that hose wall and trying to get out. Same thing here, it's coming off of the wires, all of the circuitry inside of this sauna, for example. That's the first one. The second is the magnetic field. We get the magnetic field when we actually turn that device on. Current moves, electricity moves through it, and the result, the byproduct, is a magnetic field that radiates off into space. And these fields extend 3 to 5 feet generally from any wire on the device in question. So we're going to look at both. The purpose of this project is really to shield against the electric field. The magnetic field is a bit of a different animal, and the same rules don't apply to it. So at least for stage one of this sauna remediation, we're really going to be focusing on that electric field piece. So let's get some initial readings with the sauna on and off and just see how that looks, and we can compare to that after we put the shielding in. Okay, so right now our sauna is off, and we've got our EMF meter, NFA 1000, it's set to electric field, and we're going to get some baseline readings. And again, this doesn't have to be turned on and running to get this electric field. We have about 20.5 volts per meter. And building biology would say an ideal level is about 0.3. So we're quite a bit higher already. So we'll just do kind of a grid pattern here. So in the middle, we're further away from the wiring now. We're kind of out in no man's land. We're about half of what we were over to the left, 10.8. Getting back over by this other panel of ceramic heaters, we're 5.9. So there's definitely more wires, more of a voltage difference over on the left side there. We're about 5.9 here. Okay, so now we're going to go up on the bench. About 3.3. About 5.9 in the middle position. Okay, and over to the left, about 13.5. Let's just get down here real quick. Underneath, get a 15, 18. Over here in the middle, 7.7. And over to the right, we have a 6.0. Alright, so now we are up at towards the ceiling in the back left, 35, 36, the middle, holding steady about 36, over to the right, about 24. Alright, so now with the sauna on, let's just check this again. It's about 164, and I know I said that it doesn't have to be on for an electric field, but once we press this power button at the control module, these panels become energized, whereas they are not before. It's just wires that go to the control box and above the sauna that are energized. And now we have additional wires. You can see one right here in between the two ceramic heaters that have now become energized. So these numbers are going to go up quite a bit. 165 over here, 66 in the middle, about 155 over here up on the bench. We're looking at 73, 72 in the middle, 103 over to the right, about 68. Okay, let's go up at the ceiling. Got about 28, 29, 26, 27, and 31. Okay, so we've got our before readings, and let's get this sauna out of here. And here we are, sauna removed. So what we're going to be starting with, phase one of this project, is to use a fairly inexpensive building material. This is aluminum window screen, similar to the vinyl window screen that might be in your windows at home, but this is aluminum and it's electrically conductive. So we're going to line the walls with this product, make sure everything is connected together, and then connect that to the nearby grounding conductors of the electrical system. So here we go. Okay guys, so here's part of the problem with the huge AC electric field exposure from a sauna like this. These are the electric power wires that connect to the back of the ceramic heater panels, and there's two wires here, and that tells us that they are not grounded. Grounding connections are the best way to pull electric field potential out of a space. So because we don't have that here, that's why we're going to have to do some shielding on this to make the exposures lower. And some sauna manufacturers have started doing this, adding a ground wire, also shielding these wires with an outside conduit, which is also one thing we're going to try on this project. But that's just kind of a dead giveaway that you're going to have high electric fields with anything in your house. It could, common places you see this are like with floor lamps, desk lamps. A lot of computing electronics will just have two wires, and the plug, you can tell because the plug will just have two prongs on it, not three. So anyway, there's just a little behind the scenes of why this exposure is so high from this particular sauna.
So that was a long day, but we got started on the remediations. We have pulled the metal conduit, replacing the old conduit for the sauna wires. We've added a ground wire. I'll explain that in a minute. And it's kind of hard to see, but the mesh is here. So the next steps are going to be to actually bond this mesh to the equipment ground, and there's a junction box right behind me there in the top, you can see, which is the bonding point we'll probably use. And then these ground wires that we pulled through the flex metal conduit, these are actually kind of a just in case. Depending on the results we get with just the grounded mesh and the metal conduit for the power wires, it may not be enough of a reduction. So at that point, we would create some nicely wood-framed boxes with the same mesh in it that would actually be placed over the ceramic panels on the inside of the sauna, so that they are between the source of the electric field and the person or the user in the sauna. So we may have to do that, I'm not sure. We will base that off of the results that come in.
So round one results were lackluster. Some areas decreased maybe 5%, and some areas actually increased. So we still had 150 or more on the floor, 130-ish on the bench, and 15 to 20 up at the ceiling. And this is very useful information. It's kind of pointing to the ceramic panels themselves being the main problem here. And so round two is warranted, and we'll get to that in the next section to see if we can get closer to the building biology ideal level of 0.3 volts per meter or less. Before implementing any further shielding, I wanted to do a simple test with a sheet of conductive fabric, and here I'm going to reach down and attach a grounding cable to it. Before I did that, it was about 25 volts per meter. Now it's 12, and then I'll pull the sheet down here, and it's going to go back up to about 120. So this really supports the theory of adding shielding that's grounded in front of the panels.
Alright, so I'm back. Got some results to share with you guys today on the sauna shielding project, getting those electric fields down. Let's dive in. So there's actually two types of shielding that we tried in the sauna. I wasn't sure which one was going to work the best, and so we've seen behind all of the wood planking here, we have the mesh installed. And then we also tried these custom fit wood frames with the mesh in it, which also, you can't see it, I'll put a picture up, but it is bonded to the electrical ground, which comes back here to the control panel, and that is these green jacketed wires that are bonded to the grounding terminals and connect back to the overall electrical system ground. And that's really what pulls the electric field potential away from the inside space of the sauna and back out through the electrical system. Okay, this will be a little tricky with just two hands, but we'll get the NFA back in here looking at the electric field measurements. We can compare it to before. Sorry, it's a little dim. I'll call out what it's reading, but we have 0.5, 0.6 volts per meter, 0.4, 0.8, 0.2, 0.1, 0.4, 0.2, which, as you saw elsewhere in the video, is significantly lower, 0.4, 0.5, 0.2, 0.5, As we get a little higher, we are getting some field from the lights, and I think to fully block that, we would need a similar setup with aluminum mesh over the top of those. But overall, we're still way down, so this is a whopping success. And out in space here on the bench where my client's going to spend their time in the sauna, 0.2, 0.2, 0.3, 0.3, 0.2. So outstanding results. Well, that's an outstanding result on this remediation project, reducing sauna electric field. Appreciate you guys watching it this far. And I just had a couple of closing thoughts. First of all, this isn't a knock on any particular sauna brand. Most all of them that I have seen have high electric field. So if you're watching sauna manufacturers, this may be something you want to try and incorporate into your saunas. I did do a little bit of research because I was wondering, will this shielding material block the therapeutic frequencies of light and infrared light that are coming out of the heater panels? And even though the mesh material opening is like a 1/16 of an inch, which is very small, it's still much, much larger than the sauna frequencies. So that's good news. There is still some blockage from the shielding material, but you also get some reflection. Aluminum is a very good reflector of infrared light, so I'm not sure how that all balances out. You probably lose some 10-15% of the heating and the energy output of the sauna panels, but the elephant in the room is the EMF piece, and bringing that down so significantly is going to improve the therapeutic benefit of being in a sauna like this. So appreciate you guys watching it, and we've been doing this kind of work since 2017. So if you'd like some help or advice on your shielding project in your sauna or other EMF reduction efforts in your home, definitely give us a call, and be sure to like and subscribe the video. All for now. Thanks.